And mm, today lesson will be quick as well, but informative. It will be built on top of the yesterday's one. Hi Anzar and hi Sergey. It's nice to see you. It's nice to see you. Um, okay, I think we will wait a few seconds more and we will start. Yeah, Anzar, can you please mute yourself because there is some like a background noise. Yeah. Anzar, can you mute yourself? Hi, Akimi. Nice to see you again. Trying to figure out how to mute Anzar. Okay, I will mute him for myself. You can do it as well. Just right click on him and press mute. Yeah. Oh, no, he didn't left. Okay. Okay, CryptoPunk, ACFC, Kali Linux, all famous here. I think we can start. Okay, hi guys. I'm gonna share my screen. One sec. All right. I hope everyone can see my presentation, right? So yesterday we were learning about production possibility frontier, and today we will build up on top of that, and we will explore opportunity cost and rising opportunity cost, which is very important and very intuitive notions in economy. And if you remember previous concepts that we've learned, you won't have any problem. But I will quickly go over ceteris paribus, like PPF, and we will continue building on top of that. So production possibility frontier is just an economy model that we use to calculate the best trade-offs and optimal trade-off between two variables, two things that we want to do at the same time, produce at the same time, while simplifying the whole context to make other variables that's included in production negligible. Um, our example were hunter-gatherer who hunts rabbits and gathers berries, and we've said that we just want to see if he works to the best of his ability, what is the ratio of rabbits to bears he can hunt and gather at the same time. And while we were exploring these two variables, we took all other variables like sleep, instruments for hunting and gathering, luck, and stuff like that to the zero. They were negligible. And hence we could build a model that showed us the production possibility frontier curve, which is basically all the possible most optimal trade-offs between gathering rabbits, hunting rabbits and gathering berries. Alright, and with that we can move to the opportunity cost. Let's imagine we decided to go for more protein and not berries. And let's imagine we are in scenario E here, where we hunt one rabbit and gather 280 berries, right? On the graph, we are here. So we want to go from one rabbit to two rabbits, basically going to the scenario D, right? Here, over here. What we will give up? Well, with simple math, looking at our graph, 40 berries. We can take the same amount of berries while hunting for more rabbits, right? It's out of the plot. If we hunted two rabbits and gathered still 280 berries, we would be here out of the curve, and as we discussed yesterday, we can be out of the curve on the top because it's out of our natural possibilities. So in a scenario E, to add one more rabbit, will cost 40 berries. We will from the scenario E to the scenario D. And the technical term is, well, opportunity cost. Opportunity cost of one rabbit in the scenario E is 40 berries. And the 40 berries we gave up to get one more rabbit is also called marginal cost. Marginal cost is opportunity cost of acquiring 1 point of something, anything. One rabbit in this case. So two terms, opportunity cost and marginal cost. Marginal cost is acquiring 1 point of something, how much it costs. What is the marginal cost is basically opportunity cost of acquiring 1 point of something, and opportunity cost is acquiring any how much you want points of something and deciding how much it costs. Okay, you can apply it to real world business quite easily. What will be, for example, what will be opportunity cost of making a door for the car heavier and sturdier? Marginal cost may be in dollars. Or opportunity cost may be in dollars. Basically, we will have, how would you say it, two variables, which is dollars and sturdiness and heaviness of the door, heaviness of the car door. And we will see a trade-off with how many pounds on the door we can get and how much more it will cost. Yeah, cost in dollars makes it more intuitive, this opportunity cost. Okay, let's make it stick. I will give you a quick question. What if we are at a scenario E where we hunt one rabbit and gather 280 berries, and we want to fast, eat only berries and no rabbits. So basically go to the scenario F. What will be opportunity cost of 20 more rabbits? Does anyone can guess the answer to this already? I will open the chat. And I will repeat the question real quick. Let's say we are scenario E and we want to eat less rabbits and more berries. Eat only berries and no rabbits. Basically go to the scenario F. What's opportunity cost of 20 more rabbits? Oh, sorry, of 20 more berries. No one knows? Okay, the answer is quite simple. A rabbit. Because we are at the scenario E. Here there is one rabbit and 200 berries. If we go to scenario F, where we eat 300 berries now, the cost of 20 more berries will be one rabbit, basically. Okay, so assuming we're in scenario E, opportunity cost is one rabbit. But it's not marginal cost, because marginal cost is the cost of acquiring one more berry. In this example, it equals to 1/20th of a rabbit, since opportunity cost of one rabbit equals 20 berries. Simply divide both sides of equation by 20 to know opportunity cost and at the same time marginal cost of one berry. Okay. Now let's move on to the increasing opportunity cost. Opportunity cost change as we move from scenario to scenario, and we saw it. It's very intuitive. Let's see. Basically, when we change our needs, we move from scenario to scenario, and it simply means moving on the production possibilities frontier curve, right? So here, rising opportunity cost. Here we can see when we move from scenario F, right, and we acquire 0 rabbits, we can gather 300 berries. Then to move to the scenario E, where we can hunt one rabbit, we will give up 20 berries. Then on the scenario D, one more rabbit will cost now 40 berries, not 20, 40. In the scenario C, it will be one more rabbit costs us 60 berries. On the scenario B, it's 80 berries, and the scenario A is 100 berries. You will ask why so, and we can actually think about our hunter-gatherer scenario in real life. It's really hard to hunt rabbits. Let's say you want to hunt only one. You will hunt the most slow and stupid one, right? You will kill him and eat him, and the whole other day you will be left with a lot of time. You will just gather berries. You will gather a lot of them, and basically you will sacrifice only a small amount of time in which you could gather only 20 berries. But if you try to get 2 rabbits instead of one, you could basically hunt the slow one, and maybe the second one will be slow as well, and it will be still only 40 berries. But the second one may be faster, smarter. You may be more tired from running around, and it goes on and on and on. Basically, each preceding rabbit is not as easy to capture because you are getting tired, and just by statistics, rabbits that you are trying to um, catch will be different, and some of them will be very fast, right? And by the statistics, the father rabbit will be the fastest and the smartest, and it will take more and more time to hunt each preceding rabbit, right? And more time for gathering rabbits will be given up. So yeah, as you can see, which is not always the case, but the case in our context, the opportunity cost while moving between scenarios is rising, and is called increasing opportunity cost. It may be as well decreasing opportunity cost, actually. So yeah, and we saw by taking this example to the extreme of our hunter-gatherer, of how increasing opportunity cost shows up in a lot of models as economical reality. And that's it basically. For the upcoming lectures, our material will get harder. For now, it's still very intuitive. And you still have time to play poker, nice. And thank you very much for the lesson. Guys, I hope you enjoyed it as well. Oh, a lot of likes. CryptoPunk, thanks. Yeah, thank you guys as well. Yeah, have a nice evening and have a nice play in poker. See ya on Monday, because tomorrow we will rest and there will be no lessons. Please have a nice weekend. I hope you enjoy them and spend them with your family. Goodbye.